So this video's learning objective is to describe solubility, and it's a really easy thing to do, especially when we look at how simple the rules are and how easy they are to check. So firstly, we need to go over this idea of what a polar molecule is, just so that we can understand what's going on here. So if we look at our simple covalent bond between two hydrogens and an oxygen, we know that they form this little covalent bond, and generally speaking, that's how we would probably describe it. But it doesn't actually take this shape. What it does is it makes this awkward boomerang type shape, and that means that we've got a whole lot of protons down one end and this excess of electrons on one end, so we get this uneven charge distribution. So this produces a really strong positive and negative pole, and having those two charges on either end of the poles, what it can do is it has the ability to pull apart other ionic molecules into their original ions. So essentially we have water here, and we've got some salt, NaCl, and we all know what happens when we put salt in water. It dissolves. So what happens is it moves in, and those ions get pulled apart by those polar molecules, and you end up with the ions floating in solution. So in that example, we had sodium chloride, and it dissolved into a sodium ion and a chloride ion. Now it's going to look like this as a equation, and you can see we've added a bit of nomenclature here which we haven't looked at before. So let's quickly have a look at that. So we've put these little subscript S's in. They mean that they were solid. The AQ means aqueous, but just basically means it's dissolved in water. And G, which sometimes occurs, tells us that it's a gas existing in a gas form. Now, with solubility, we need a couple of key terms here to describe what's going on. So our first one is this idea of dissolve, which we all know. It's when a solid becomes incorporated into a liquid. We're all comfortable with this one. Solute is the solid that dissolves. So in the previous example we looked at was NaCl was the solute. The solvent is the liquid that the solute dissolves in. So in that case it was the water. And the solution is that mixture of the two. Another term we need is soluble. This is going to be really important for when we're looking at precipitation reactions. So the idea of soluble means that it's able to be dissolved, and insoluble, it's not able to be dissolved. So if we were to do this experimentally in the classroom, what we could do is analyze a bunch of different chemicals, basically compounds, throw them into water and see if they're soluble or not. Fortunately, what we have is a table which tells us, and this is the beauty of solubility, is all we need to do is look at the table, and you can see I've highlighted now the ones that are soluble. So if you've got any sort of compound that has a nitrate in it, let me pull up my periodic table. So we could be talking about magnesium nitrate, for instance. I can see that it is a nitrate on my list, so it must be soluble. Anything in the group 1 there on my periodic table, so on the far left I've got anything that lithium, anything with the sodium, anything with the potassium, anything with the rubidium, they're all going to be soluble. You can see though if you go down to the green one there are exceptions to this rule, to the rule. So anything with a chloride, a bromide, and an iodide is soluble unless it is silver bromide, silver chloride, silver iodide, or has a lead chloride, lead bromide. So you just basically follow the rules and look for those exceptions. It becomes very straightforward. So here are the ones that are insoluble. And it is really that simple. If you have any questions about solubility, please don't hesitate to ask your teachers. When you have a look at precipitation reactions, you'll see that this follows straight through. So you need to really understand solubility before you can understand precipitation.